This session, we would be looking at directory traversal attacks. I have this vibe coded front end here with two routes. I have the API files route and also the API file secure route. So before we look at our demo, let's quickly navigate to our projects to understand the structure. We have this uploads folder here with the report.pdf.txt and also a welcome.txt file. We also have in the root directory our passwords.txt file, which of course contains certain environmental variables that we don't want users to access. The issue with directory traversal attacks is that it takes advantage of insufficient validation and sanitization of user supplied file names. So let's try and access this welcome.txt file that we have in our project. So we have API, the files route, the file name is welcome.txt. We have a welcome message. Welcome, this is a simple file upload, blah, blah, blah. So this is a file that we just want every user to access once they visit our site. The issue with directory traversal attacks is that by just traversing the directory, we can actually access any file that we want that has not been secured. So let's try and access this password.txt file. Before then, let's quickly have a quick look at the location of this passwords.txt file. The password.txt file is located in our root directory. So let's move one step down and see if we can access the passwords.txt file. So dot instead of forward slash, and voila, we have our environmental variables visible in our browser. And this is a security vulnerability that you have to take note of, because you don't want data such as this to be accessed by any user. First of all, look at how to solve this theoretically. This is the file structure that we have, the uploads file section, which contains the images folder and also contains the welcome.txt folder. Down here also we have our passwords.txt file as well. So the engineer is actually rendering images on the site, and the route looks something like uploads slash images slash img, which is equal to the ID of the image being rendered. Now, one thing about this routing structure is that we are actually exposing the folder structure of the project that we have. So by just directory traversal, an attacker can actually explore this path structure and maybe just add two dots and a forward slash and try and access files that are located beneath this. So maybe the password .txt file, right? So first of all, we are actually exposing the file structure that we have, and secondly, we are not sanitizing input. We can actually just use the routing structure file slash image, and this is equal to the ID of the file that we are actually rendering, which is 123. So instead of using all this, you can actually just use this route and render the image or the file that we actually want to render. Now, the second way we can actually prevent this attack is by sanitizing inputs. So every input that is actually rendered in the last word of our file path needs to be sanitized. So any dots before it has to be stripped off so that attackers can't access files that are located beneath the file structure or the folder that we are actually rendering. So if you want to render images from this upload section, you want to strip off any further dots that are actually provided from this route. Right, so when the attacker tries to traverse this directory, it's only going to render the words that are actually located after these two dots and a forward slash, which are used to access files in different sections of our folder structure. Now, the final way we can do that is by using cloud storage, such as Cloudinary. So instead of rendering images from a static folder, we can actually upload these images to a third-party cloud provider such as Cloudinary. And Cloudinary actually presents us with the image URL that we can actually render in the project that we have. So it's going to look something like this, of course, with the ID of the image that has actually been uploaded. So we've seen three ways to prevent this attack. We've seen the first way, which is not exposing the file path. The second way is also sanitizing input. And the third way is also using third-party tools for image or file uploads. So third party will be the name of the third point. So now let's have a quick look at how to prevent this attack in a real life coding session. This code. The user passes a file name from the request query, and the file name is directly passed on to the parent directory without any sanitization of any form. Also, there is no list of files that are actually accessible by the user. So any file goes. So provided we have an env file in our directory, such as this, that has not been put into our get ignore, so that it's not uploaded on GitHub or any third-party tool that we are using to render our project. The env file is can actually be accessible by any user through directory traversal. And if we don't specify files that a user can actually access, it's going to be a problem. So let's look at how to solve this in the file secure.js file. Now in this, we use the path.basename file to strip all leading slashes or dots from our request query. Also, we have a list of file types that are actually accessible by the user. So if a user wants to access an env file, it won't be accessible because it's not in our list of allowed files. Now, these are two ways that we've seen practically. The other ways that we've also seen is uploading the files or static files to third-party tools such as Cloudinary, so we can just render the URL. Also, we've seen that we don't have to make the path of our static project too visible. So in this case, the user should not know that the image files are actually loaded in the image folder, which is also embedded in the uploads folder, so that the structure of our project is not too visible. Thank you very much.